In the lectures so far, we've been considering various kinds of data, and all of the variables have been what we call quantitative variables, variables represented by numbers that can be larger and smaller and so on. Now we're going to discuss other kinds of variables, which are called categorical variables, and they're variables that just aren't represented by numbers, and we'll see how we can think about them. For context, let's remember that life expectancy data that we looked at before. This gives the number of years that people live on average in 197 different countries and territories around the world. Because these data were represented by numbers, it meant that we could compute things. We could talk about, for example, the minimum value and the maximum value. We could talk about the median. We learned about the quartiles. We used that to draw a box plot. We also computed things like the mean value and the standard deviation. We could plot things like histograms. We could talk about if they're skewed or if they're symmetric. We could talk about the extreme values of the data. These are all things that we can talk about if we have quantitative data. But there's other kinds of data too. So let's go back to that data about life expectancies and think about where it comes from. Each of those countries and territories is represented somewhere in this map. Now the data that we got also divides up the world in terms of different regions. And the way they divided up the data, they talked about the Americas, North, South, and Central, as one region. They talked about Europe and Central Asia as another region. They talked about East Asia and the Pacific as another region. They talked about South Asia as a fourth region, and the Middle East and Northern Africa as a fifth region, and finally Sub-Saharan Africa as the sixth region. In that way, they divided up the map into 6 regions. Now, that gives us some data too. If we want, we can make a list. Here's a list of those 197 different countries and territories, and for each one, which of the 6 regions it belongs to. Well, once again, it's just a jumble of text. How can we make sense of it? Let's start by considering what we did for the quantitative variables, things like the minimum and maximum and median and quartiles and box plots and mean and standard deviation and so on. Can we use these for a categorical variable like the region? No, we can't. The reality is hardly any of these things make any sense anymore for a categorical variable. So what can we do? Well, one simple thing we can do is just count. We can say how many of those 197 different countries and territories are in each of those 6 regions. Well, here's the count that we get. We see that there's 39 in the Americas, there's 50 in Europe and Central Asia, there's 30 in East Asia and the Pacific, there's 8 in South Asia, there's 21 in the Middle East and North Africa, and there's 49 in Sub-Saharan Africa. So now we have a table of numbers, and that's okay, but there's other ways we can represent it too. One nice way is what's called a bar chart. And a bar chart, as illustrated here, just presents a separate bar for each of the different categories, in this case each of the 6 regions, and for each one the height corresponds to how many elements are in that region. So in that way, we've represented the counts as a nice looking little chart. Now, if we prefer, instead of representing the counts, we can represent the relative frequencies, which is just what fraction of the countries and territories are in each of those 6 different categories. That's illustrated here. It looks exactly the same, except that we've divided by the total number, so now the heights of the bars actually add up to 1. Another way that we can illustrate that same data is with a pie chart, as illustrated here. A pie chart considers a round circle or a pie and chops up slices of it in proportion to how many of the data fit into each of the different categories. In this case, how many of those 197 different countries and territories fit into each of the 6 different regions. Now, pie charts say pretty much the same thing as a bar chart. We won't use them as often, but some people like them. In fact, some people have fun with them. Here's a cute little pie chart showing the amount of pie somebody's eaten or not, taking pie a little too literally. And here's another one that I think is quite cute, where they illustrate sales of Girl Scout cookies by actually making a pie out of pieces of the different cookies. Very clever. Anyway, the important thing is to understand that when you have a categorical variable, you can illustrate the counts by using either a bar chart or the relative frequencies or a pie chart. So that's pretty much all we can say for now about categorical variables. We'll get into them more in next week's lectures when we discuss the relationships between different variables. But for now, let's consider one more example. Let's go back to that skeleton data we had before from the anthropologist. Remember that this had various information about 400 different skeletons that had been studied. Well, we already talked about things like the estimated age at the time of death, or the difference between the estimated and the true age at the time of death. And those were quantitative variables, so we could talk about the minimum and the maximum and the median and box plots and quartiles and mean and standard deviation and all those things. But what about some other variables? For example, each of those skeletons has a sex. Is it male or female? Well, for that data, it turns out that 281 of them are male and 119 of them are female. So that's a categorical variable. You can't take the maximum or the minimum or the mean, but we can draw a bar chart. And here's a bar chart showing the sex of those 400 skeletons. If we want, we can also show the relative frequencies. Or if we prefer, we can make it into a pie chart. Another example of a categorical variable for these skeletons would be the mass category. That is, each of these skeletons, the people at the time of death, were categorized as being of normal weight, or underweight, or overweight, or obese. Now in this case, 225 of the 400 skeletons were classified as normal, 74 were classified as underweight, 81 were classified as overweight, and 20 were classified as obese. Again, we could just make a table, but we could also display that as a bar chart, or if we prefer, the relative frequencies, or if we prefer, we could make a pie chart. In this way, we can illustrate the categorical variables, not in as much detail as the quantitative variables, but we can still say something about them. As we move forward and discuss the relationships between different variables, it will become more and more important to understand the categorical variables as opposed to quantitative variables and how they all fit together.